Okay, here we are, second installment. We're going to do the arithmetic geometric sequence stuff first. So what's going on? Identify the type, find the next couple numbers. It looks clearly like they're doubling, so that's 16 and 32. The formula then is going to be the first term times the magic multiplier 2 to the n minus 1, and then that's a sub n. You should put that in. You could also say, well, no, I'm not going to simplify that. Leave that. That is totally awesome. The 10th term then, you could just simply carry this out 10 times. This is the first, second, third, fourth, fifth, sixth, seventh, 8, 9, 10. You double it 3 more times. 32 to 64 to 128 to 256. So 256. You could also just put this in your calculator. Oh, this is no calculator, sorry. So you have to just keep doubling it. The type is geometric, and the limit is none. You could write infinity too, I suppose, if you wanted. It just gets bigger and bigger and bigger. All right. This one, caret numbers always help. It's going up by 6, going up by 6, going up by 6. You want to check that. So that's 37 and 43. The formula then is your first term, 13, plus the magic, the common difference, it's called, 6, and then times n minus 1. All right. You could also, distribute that and come up with a simplified version, which would be 6n plus 7. So both of these would be correct answers, either one. And write a sub n. All right. Don't give you bad habits. All right. So now for 1,000, this is much easier. You can see this is 6,007 when I put in 1,000 right there. Here you still get the answer. It just would take you a little bit longer to do the math. This is an arithmetic, and there is no limit. It does keep getting bigger and bigger and bigger. All right, so here we go. 1/10, 2 100ths, 3 1,000s, 4, 5, and then count 4 zeros, so that's 5 zeros. And if you wanted to write 5 over 10 to the 5th, that would be clever. And then this would be 6 over 10 to the 6th, or you can count out 6 zeros. That's all right. And that would be 1,000,000. The formula then is going to be n over, well, it's going to be 10 to the n. All right? That's your formula. A little bit of fishing around, mathematical smarts. The 10th term then is just going to be 10 over 10 to the 10th. All right? You could write out all the zeros and all that if you want, but that would be fine. This is neither, but it does have a limit. And what's this limit approaching? 0. It's getting closer and closer and closer. This decimal is getting closer and closer to 0. All right, now on to our favorite recursive formulas. These are the seed numbers that get us started. So I've got 1 for my first term. For my second term, I've got 3. For my third term, I take the previous 2 terms and multiply them. That's what that's saying. A sub n minus 1 is the term before a sub 3. A sub 2, that's 3, times the one before that. So 3 times 1 is 3. 3 times 3 is 9 for the fourth term. I only need to go up to 5. 3 times 9 is 27. It's going to get very big very quickly, but that's what it is. All right, on to the calculators allowed section. All right. If a regular polygon has an interior angle of 150, or this is 150, well, we're going to use the exterior angle of 30 to help us find out how many sides. That's going to be 360 divided by the exterior angle of 30 gives us 12 sides. Okay. If a regular polyhedron has a defect angle of 60, then how many faces does it have? All right, well, you know that 720 is the total of all defect angles. And if I divide by 60, then I get 72 divided by 6 is 12. So I get 12 vertices. Okay, so if it has 12 vertices, it could have 5 on the top and 5 vertices on the bottom, and you're going to wind up with 12 faces as well. All right. This is the critical thing. I actually think that I misworded that. I should have put vertices on the test. If I did one of these, it would be vertices. Moving right along, here we have 10 to the x equals 4,567. So I'm going to take the log of both sides. When I take the log, common log, the x comes out front, and log base 10 of 10 goes poof. So this is just the log of 4,567. All right. So type that into your calculator, and you'll get your decimal answer. All right. So I think, in the interest of time, I'm not going to always do this, but 4,567. And it's 3.65 or 660, approximately 3.660 when I round to 3 decimal places. All right. Solving this one, I take the ln or the log of both sides. It doesn't matter. So ln will sneak in there, sneak in ln, and then the x comes out front. So I have x, then ln of 7 equals the ln of the 7,890. So then I just divide both sides by ln of 7. And so again, taking ln 7890 and then dividing by ln of 7, and I get 4.611 approximately. All right, these are all going to be approximate. You can make that wavy equal sign or not. Log base 3 of 5. Well, the simple change of base formula is the ln of the top number over the ln of the bottom number. That's the base number 3. ln 5 divided by ln 3, and I get 1.465. Okay. So now this is a longer solving one. It's just peeling back layers of the onion. I'm going to subtract 100 to work from the outside in. That'll get rid of that. And then I'm going to divide both sides by 10. I guess I'll write it in stages. Times 5 to the 10x minus 3 equals 6,307.20. And then divide by 10. So divide by 10 cancels those. Divide by 10 cancels a 0. And then when I take the log of both sides, 10x minus 3 comes out front. ln of 5 equals then the ln of 6370702. And I'm going to divide by the ln of 5. And then I'm going to add 3, put that all in brackets, and then I'm going to divide by 10. Okay, and so crunching out those numbers, ln 63702 close parentheses divided by ln of 5. That gives me an answer that I'm going to add 3 to, and then I'm going to divide by 10, and I get, this is approximately equal to 1.130. Alright, and the beauty of this is I can always plug that in and try it on my calculator if I have time. Alright, if a car is purchased in 2007 for $32,000 and it depreciates at 9%, it's going down in value 9% per year, how much will it be worth? I should have had, write an equation. You definitely want to write the value of the car over time is going to be its starting value, 32,000, and then 1 minus 0.09 to the t is my equation. But actually you could also say that this is continuously depreciating. Every minute, every second of the day it's depreciating. So better equation will give you slightly different answers, is the value of the car is 32,000, and then just e to the minus. When I do this, the rate is negative 0.09. I can write that negative 0.9t. and because that's my rate, it's losing 0.09, and that's the amount of time. All right. So how much will be worth in 2015? If I put in 15 right there and do the number crunching, let's check it out. So 32,000 times e to the negative 0.09 t. Sorry, t is in 2015. That is 22 years later, times 22. Hit enter. So it's worth approximately $4,418.21. Let's just, for variety, suppose I'm doing it this way. That is also going to be 32,000, and then times, and it's going to be 0.91. I'm losing 9%, so keeping 91%, and then that's to the what do we say, 22nd power. Oops, caret to the 22nd power, and hit enter, and that's it's worth 4,018. So it's got the value is being lost a little bit more quickly that way. All right. How long will it take to be until it's worth 5,000? Well, this is where logarithms come in handy. You can write $5,000 is what your $32,000 car, e to the negative 0.09 t, is going to be worth. And so when I divide both sides by 32,000, so I'm just going to solve this in the calculator here. So divide by 32,000, and then I'm going to take the ln of both sides, and that will make this come out front when I take the ln, and that goes poof, so I just then need to divide by negative 0.09. So ln of 5,000 divided by 32,000, and that then will be divided by negative 0.09, and I get 20.62 years, approximately 20.63 years. And you'll see if you use this equation, it will be slightly different, but you'll still get maximum credit there.